right, so as Nestor said, my name is Kush. I'm going to talk about open source AI, and we'll get to what open source AI is, because I'm sure some of you are wondering what AI is in general in terms of its usefulness. Basically, the perspective that I'm bringing you is that of how AI should be seen as a tool, should be seen as simply a technology and not as some sort of another type of human or another type of sort of new thing that exists. AI is just another technology in the sort of spectrum of all the possible things that we have come to use and love over the last centuries. So anyway, I am a sort of software engineer primarily, and Nestor I think talked enough about me, so I'll skip this. In terms of AI, you may be familiar with obviously old school AI ideas about AI that is sentient and has its own agency, and talks about how and can sort of take actions on its own behalf, act in the world, like in movies like Terminator and so on. You may be familiar with AI in the sense of video games, when you're playing with a non-human player and it takes actions and it plays with you, even though you're not playing with a real person. You may know AI in the modern sense of ChatGPT, applications that you can use to simply augment your workflows, do things faster, do better things, etc. I specifically talk about AI as these small technologies that are sort of everywhere around us, that help us do things that previously, let's say a decade ago or 2 decades ago, were things that humans would do, but now computers can do for us. And so that would be things like, for example, speech recognition. So before, if you had to write something down, you would either have to type it up yourself, or you would have someone taking dictation and typing it up for you. You would have some mechanism, some variation of that. But now in the last sort of 10 years, and especially recently, you have speech-to-text technologies, which are taking voice as a type of data and converting it into text as a type of data. And that means you can simply talk live to your computer and it's able to type on your behalf. I'm sure you've all used it on your phones. It's not a new technology, but it is new enough in the spectrum of what's possible. So that's kind of part of AI, but it is part of AI. It is using something internally that is in the spectrum of technologies that is under the umbrella of AI. Something else you might have used before now is translation. So it used to obviously be people who are sophisticated, intelligent translators who are going from French to English or English to Spanish, who are hearing people talk about something, thinking about what it means in a different language, and then relaying it to the other person. Now you can just have a computer do it to some degree of accuracy. So this is AI again in that sense. Or AI in the sense that a computer can now do what humans did before, because you intuitively think that there is some amount of intelligence involved in doing such tasks. So again, artificial sort of intelligence. Another sort of example of that would be just even text to speech. So taking any kind of transcript and converting it into something that you can hear back immediately. Because if you've read books, you may be familiar with audiobooks, obviously, and so we've enjoyed that in the last 10 years, 15 years, being able to simply hear them, have someone read them out loud. Obviously, the way they've been built till now is someone sit down, very thoughtfully, read the source material and narrated that story, and you consume it. But now you have computers doing something like that, simply converting text into human understandable speech. So these are the small pieces of technologies that I consider the most valuable and the most important pieces of AI, not AI as Terminator or not AI as an assistant that does everything. So within that, with having set that up and my focus in AI, my goal with this talk is to specifically target the text side of it, the natural language processing field, which is basically a subset, a very small subset, very impactful subset, but a small subset of the field of AI that has to do with language and how computers can now understand language, understand being sort of general word that I'm using here, and how computers can process language and do something with it. So ChatGPT is an example of that. It's an example of NLP being applied to help you in some way. So I'll talk more about that field, and specifically I'll try and really demystify what's happening on the very internal level in these technologies. So because right now I feel like there's a lot of just confusion and intimidation by these technologies that seem so capable, that seem so intelligent, that seem almost human, like a new species is born. But once you really start to look into it, you realize it's just sort of addition and subtraction, and it's just sort of statistics. And so I'll try and make that obvious to you, despite your level of sort of understanding in technology and software. So yeah, NLP is the field I'm going to focus on. Just quickly also, I will mention that what I won't cover in this talk, but I will in the future at some point, is computer vision and computer graphics, CV and CG. These are different fields outside of NLP, and those would have to do with when you have a computer generating images for you. So I'm sure you've probably seen Stable Diffusion or Midjourney or DALL-E, where you ask your computer for a picture and it just creates it for you, just paints a picture for you or so on. That's a different field. There's also fields where, for example, a camera position here could count the number of people in the room and do something with it. It could count the number of men and women. It could count the number of chairs, number of empty chairs. At the shopping sort of mall, it can count, or it can figure out who picked up what and keep track of that. These are all applications of computer vision. So this is, instead of understanding language, it's understanding pixels, it's understanding the state of the world. Again, things that I won't cover necessarily in this talk, but something to mention that that's another field of AI. And then CG is computer graphics, more having to do with sort of video games. I'm sure you've seen video games come a long way in the last decades, and looking a lot more realistic, being able to run that much better on smaller computers. A lot of AI technologies go into that, how that's done. Again, not the topic of this, not the subject of this topic of today's talk, so I'm going to skip it for now. But I wanted to mention what I won't be covering. So in NLP, in natural language processing, the core artifact, the core technology that I'm going to really talk about, that's been exciting to most of you, I would imagine, and just it's caught the attention of the world, is large language models. So large language models, or LLMs, as you may have heard or not heard, is the technology that's running ChatGPT. It's the engine, it's the brain behind a technology like an application like ChatGPT. Because ChatGPT is just an application. It's not a technology. It's the thing that you use. But what's running it is computers, electricity, and one of the things that's running is LLMs. So I'm going to talk really about, in the rest of this talk, what LLMs are, how they work, so you can really sort of feel a lot more comfortable with what's going on under the hood with these technologies. Before I go into it, actually, just for my curiosity and because I love knowing my audience, I wanted to survey the audience and see what your backgrounds are, so I can sort of try and cater to various perspectives as I go. So how many of you here have used ChatGPT before? All right. Seems like almost everyone, but some of you have not. How many of you have built software before? All right, there's a decent amount of people. And how many people are in like creative industries in general? Okay, cool. And I'll also be wondering how many of you have heard the word LLM before? Oh, okay. Wow. Okay. So a lot of you people, you've been reading up and actually understand what's going on. That's great. So it gives me a sense of like what gaps to fill as I go through it, and also sort of what points to hit so that I maintain your curiosity or attention throughout it. So like I said, LLMs. Let me see. Okay. LLMs are fundamentally LLMs or large language models are the artifact. It's like this sort of shiny object that's produced by most often these big companies like Meta or Google or whatever, because it requires a lot of money, by compressing a lot of knowledge. Fundamentally, I see it as knowledge compression. So it's basically taken the entire internet, or almost the entire internet, the public internet, every single website, every single just document, books, not every single, but a lot, and just compress it. Basically, think of it, just compress it into a few gigabyte file. So obviously you guys understand like file sizes and so on. Seems like I see a lot of nods. So it's simply taken the entire internet, which is in this case of the specific one that I'm showing you, 15 trillion words, right? Trillion words, that's crazy, and compress it into a single file sitting on your computer, say a few gigabytes, 5-6 gigabytes, right? So fundamentally, LLMs are that artifact. It's that final output file that was produced by crushing all this information into a small space. How it's done, I'll talk about it in a moment. But that's what's happening here. Once you have this file that is some sense of compression of the information, it's then used to drive applications like ChatGPT, drive applications that like various other things that are using LLMs. So what does it mean when I say compress the entire internet into one file? And what are the implications of that? So first of all, just to give you a sense of what I mean by compression, is it was data. The data that was given to this machine that was eating it all up and finally producing this model was data like this. So technical blogs on the internet, like maybe Stack Overflow posts, maybe any kind of thing that you may be interested in, whether it's sewing, whether it's software, whether it's something else. You'll have blogs that'll have like, okay, for JavaScript developers, like here's blah, 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 some text here, some text there. It's just a small clip of like a massive article or a million trillion articles out there on the web, right? Another example of the kind of data that was consumed in the process of training, which I'll talk about what training is as well, it's basically compressing, was fan fiction. People are writing, stories about Captain America or some other character on their own on the internet, like for the last so many decades. I'm sure all of you have participated and created your own work and published it. So it's there on the internet, and it was consumed by this process in training. I think I also highlight stuff like this specifically because we all should take ownership of this technology, of this model. It's our data. It's what our contributions were to the internet over the last entirety of the existence of the public internet that has resulted in this technology being possible. If we all did not engage and did not create our art, did not create our work, did not contribute to society's benefit, did not publish our photos, our feelings, our notes, and our guidance, it would not be available for the creation of this AI technology, this AI model. And so we should feel proud that we contributed to that, and we should demand ownership of it as well. So we should not sort of assume that somehow OpenAI or some company in Silicon Valley created this thing all by themselves. They did not. Without us, they would not be able to do it. Another example, by the way, of the kind of things that this training process ate was just a lot of code. I want to make sure it's working. There's a bit of a delay. Okay. So it's code. So just a lot of code, like seriously billions and billions of lines of code, because the internet is full of just people writing code, sharing code, talking about code, and even in general, everything that is the internet that you see underlying has code in it, code behind it. So because of that, if you've seen these models be really good at programming, at generating code, it happens to be because it just saw a lot of code in its process of compression. So as a result, got really good at code. So again, how does it actually compress information, which is, let's say, millions of gigabytes, into like 5 gigabytes, for example? How does it really happen? It's because, or the reason that that's able to happen is because, just give me 1 second, this is annoying me, it's taking a while. There's a delay between the screen and my screen. Cool. Before I continue, actually, I'm going to ask for Mike's help. There's a delay between the screen and my screen. Is there any chance that I could fix that? No? It's like a massive delay. Like I'm on a different screen right now. Okay, no worries. I'll figure it out. Yeah. Cool. Okay. So yeah, the way that it happened was during the training process of creation of this artifact, we basically said whenever you see the sentence, it's not just about writing code that works. It's about this process was supposed to predict the next word. It was supposed to predict what comes after or what's come after all this? And it would either give back writing, or it would give back some other word. And if it wasn't writing, they would say, you know what, you're wrong, try again. And you might be like, well, it seems like a pretty ridiculous process. There's like millions of words. How does it actually get right? Yes, it actually is that crude, the training process. It happens to just keep saying, you're wrong, you're wrong, you're wrong, you're wrong for the most part, till it eventually figures out that it was writing, and then goes ahead and says the next word again, writing efficient, goes next word again, comma, next word again, non. So, and then eventually it just gets better because it sees enough times that code that is followed by works, that next, let's say, 5,000th time it'll be better at it, and 1,000,000th time it'll be better at it, and 1,000,000,000th time it'll be really, really good at it. So during the training process, it was just given like partial sentences and asked to predict one word after that. That's all it ever did. And as a result, it really had to understand internally some knowledge about the world. Like, because if it was trying to store this specific sentence, it's not about just about writing code that works, and like this sentence and that sentence and every single sentence in a way that was completely compressed and then irreversible. It would not be able to do that because there's too little space for it. But it would have to understand the fact that code is something that's written and it's generally supposed to work, and there's some benefit to having it be written efficiently. So these are all just concepts it's compressing into this internal space. This is more of a complex topic even I don't have that much understanding of. But as a result of that act of compressing it, it's able to now write sentences, not just like this specific one, but any sentence that would be about code that works, that's written, and that's efficient. So it just has internal understanding. And of course, this sentence is not unique. This kind of sentence, this type of concept about writing code that is efficient occurs all over the internet, right? Similarly, people talking about pizza being warm and being tasty occurs over and over all around the internet. Same thing with relationship advice or any kind of other topic. There's a lot of commonality, a lot of similar conversations happen all over the world on the internet. And so it's able to say, you know what, I'm seeing this concept enough times, I'm going to compress it into a representation that says whenever two people are hungry, they are likely to go to a restaurant, something like that. And so whenever a conversation about restaurants comes in and two people are involved, the model knows what to generate next. So moving on from this topic, the first artifact that is produced during this training process, when all these big companies are throwing that much data at it and produce that file, is called the base model. So generally, when you're using ChatGPT or any application like that, you're not interacting with this thing specifically. You're interacting with something that was built on top of this after the fact. But the very first act, the very first thing that's produced after the several $1 million spent on training is called the base model. The base model is basically a file that is able to be given a prompt, given a piece of text, and it produces the one word after that, just one word, right? So once again. So for example, if I and then it just produces one word, and then it says next word after that, next word after that. So if I have a prompt like once upon a time, it'll just keep producing one word after another. There was a little girl who lived, and it'll just keep producing that sentence, right? So if for example, I say in a land far, far away, and just let it go, just keep producing the next word endlessly, it's going to say in a kingdom called the Kingdom of the North, there lived, and it'll just produce the story. It's just completing the word, the next word. I'm sure, how many of you have used autocomplete on your phone before, right? So it seems like a pretty obvious thing we've used for many times. This is the exact same thing, literally, just way more money spent on this, and let's just say 10 years ahead or 5 years ahead. So all it's doing at this point, the base model, having spent millions of dollars, is producing the next word. So you can't really ask it questions, but the knowledge is there in there somehow. If you guys know this code, by the way, if you wish to make an apple pie from scratch, you must first invent the universe. Carl Sagan said this. I love this code. I think it's very appropriate because these models have to really come up with a very compressed fundamental understanding of the world to be able to store all this information, all this knowledge about it in these very small weights. So yeah, this gives you a sense of like, okay, these models are just finishing sentences, but how do we go from there? What do we do next? Well, I'll get into that in a moment, but to give you more intuition, I wanted to talk about that specific thing that I talked about, which is next word prediction. All these models are doing is just predicting one word at a time. You may have heard of it in like funny conversations on the internet, like, oh, this model is just predicting the next word, and then some people are arguing about, no, it's very intelligent, it's going to take over the world, and there's a big debate going on about it. But fundamentally, that is what they're doing. It's just predicting one word at a time. That's all its goal in life is, just one word, right? So I created like a little visual to be able to visualization to show you like how it works, and maybe I'll sort of engage you guys as well for suggestions. But in this one, you'll be able to see not just the one word that it generates, but also some suggestions of what other words it might generate. Because fundamentally, when these models are asked, for example, once upon a time, it doesn't actually just generate the comma. It actually has about 100,000 words that it could pick from, comma, there, whatever else, and it ranks them. It ranks them to be the most likely word and then the most unlikely word. And there's a whole spectrum. So for example, comma is the most likely word according to this model that goes after once upon a time. There is the second most likely. Once upon a time in is the third most likely. And then somewhere far down, like 100,000th number is like zebra, or like bananas or whatever. Once upon a time bananas. I guess it makes sense. Once upon a time exclamation mark even makes less sense, right? So I created this visualization to be able to show you that these models aren't actually picking the but generally speaking, they will pick the very first one always. So if you ask, for example, the question once upon a time, or to complete this, it'll always give you the same story. This is very important to highlight actually. These models have only one best word that they think when they are trained is going to be the next likely. So while you may have asked ChatGPT the same question and gotten different results, that's because there's some processing, manipulation, extra effort happening on top of it that's allowing us to get multiple answers. But fundamentally, given the same prompt, the model will always generate the same specific sequence of characters. So that's because it's always picking the first option, right? It's picking comma, it's picking there was a little girl. As you saw, it's the same answer. It's just picking it. At each given point, it had other options to pick from. So if I go back and I say once upon a time, comma, or I actually want to say once upon a time there was, or there were two, or there were three. It could have picked either. There were two seems very likely, but it could also pick the three if I said don't always pick the obvious answer, go somewhere around the obvious answers. So there were two brothers, sisters. There were three brothers, three little. Three little sounds actually kind of more fun than three brothers and three sisters. So it's got add three, right? Three little pigs, three little girls, three little bears. And so all it's doing is just making up the most grammatically coherent next word. This is very important to highlight that these models fundamentally, internally, same thing that's driving ChatGPT, is not thinking. It's not thinking of the best answer. It's not thinking of the most creative story or whatever. It's just trying to keep the sentence grammatically coherent, so that it actually just makes somehow grammatical sense. And so if you try and deviate it, it actually will get confused. Did you have a question, please?
If when it picks words or the next construct to use, is it doing so based on a set of there's a psychologist named Noam Chomsky who's familiar to some people for political things, but he talked about internal cognitive structures that are sort of pre-wired in humans. Is this doing something similar to that? It has a set of rules that it uses, and then it constructs the sentence based on that, or is it just purely predictive based on its experience of consuming a trillion different possibilities?
That's a really good question. So to repeat the question, you're asking about. So first of all, if you're familiar with Noam Chomsky, he's a linguist, like a very prolific contributor to the field of NLP, natural language processing, especially before transformers, the sort of newest way of doing things, just throwing lots of data, compressing. Before that, his sort of and his peers' research efforts were a lot more interesting because they were all rule-based, as you mentioned. So your question is. When the story starts getting generated, once upon a time is it saying there was is because of the language patterns that humans generally speak, that Chomsky and so on mapped out, and so it's speaking based on that intelligent sort of thought, or is it just doing it based on the fact that it saw 15 trillion times that once upon a time was followed by there, and so it's just doing that? It's the latter. There is no thinking going on. There is no rules. In this specific model, especially these things called neural networks, it is just doing a predictive model based on just the frequency that it saw it as. Now, the important thing to know is that it didn't just see once upon a time there. It saw a massive paragraph and then followed by once upon a time there. And it saw all kinds of stuff. So if I have once upon a time like this, it might be there, but maybe if I say once, comma, it might not say once upon a time, or upon is, so once is not followed by upon if the comma is there. So it's a once, when, the world. So it very much is just based on the data that it saw. This is extremely important point, so I appreciate the question. And so, for example, in a land far, far away, there lived to princess. So something I wanted to sort of highlight as well is you see how you may have heard the word token in relation to language models, and you may wonder, like, what's tokens, what's words, what are things priced differently, blah blah blah. I mean, not blah blah blah, it's interesting enough to me, but it's because tokens are a way of splitting up words so that we don't have to deal with like millions of words, because there are lots of words, especially variations, right? Like with ing and es and all the, like, just variations of words, you know, highly, high, etc. And so if you see the one in land far, far away, there lived two. The suggestions it has, the best ones are two sisters, two brothers, and two princess. Two princess doesn't really make sense because it's a singular. It should be two princesses, right? But it's because princess was not common enough word in the, let's say, the, you know, in the top 100,000, which is kind of the vocabulary of this model, 128,000. Then it said, you know what, I'm going to split princess up into princess, or princesses up into princess and es for optimization purposes, just so that we only have to ever deal with 100,000-ish number of words. So if I say two sisters, it'll say something else. Two brothers, it'll say whatever. But if I say two princess, it'll say es, because it knows that it's supposed to follow by es to finish the actual grammatically correct sequence, right? Two princesses. So if you heard the word token and words and you're confused about where that belong, token is simply words split up to be just optimal for speed and training purposes and just various other reasons that would be pointless to go into because there's more fun stuff to cover. Field of natural language, blah blah. Yeah, these are all just fun examples. I just play with it. Please, yes, another question.
Just with this type of thing, are the companies or organizations that have large language models, are they using AI to train their models? Like, is this kind of a circular thing?
It's an interesting question. I think maybe you're asking if the training process has evolved from the benefits of the things that they've already accomplished, and are they feeding back that information? Currently, at least as far as the existing architecture, like this model that I'm using, it's called the Llama 3 or Llama 3.1 by Meta. It's basically a defined pipeline or defined way of thinking, defined way of training that people have come up with. They keep changing it, like of course evolving it, but it's just like some mathematical code that they write that from their years of understanding the stuff, and there is no necessarily AI or there is no intelligence of that sort involved in the training process. It's just compression. It's just old school compression, like a zip compression, but just in this case very lossy, which means like they're not going to give you exact sentences back from the data that they saw. But so the process of compression is actually pretty well thought through. There's innovations on that side happening, but your question might be also coming from the perspective of like, well, wouldn't this AI now be able to help write better code, to help create better architectures for the next AI? And in that sense, it is helping because the researchers who are being able to use their time better by multiplying their productivity and use AI to write better code and just create more variations. In that sense, it might be feeding back. But fundamentally, it's just under the scenes, it's just some software engineering and math. Nothing really that intelligent. The artifact itself is somewhat intelligent, or at least looks that way. I had a few examples as well. So in this demo also, I created this to be able to show you a few different aspects of it. One is that, so like I said, it just completes the next word just based on grammatical cohesion, and so it's not really thinking. The other is that it's really very much bound by what you've given it to work with. So if I say I'm here in, I don't know, What's that? Yes, I'm here at the VPL. I'm here at the VPL. Maybe it knows that VPL is in Vancouver. Okay, San. I wonder. Okay, well, maybe there's a VPL in San Francisco, but let's say in Vancouver. Vancouver, I should say Canada after this probably. Vancouver, BC. So because I gave it Vancouver, it knew that BC is probably going to be after this because Vancouver, comma is generally followed by BC. To talk, or let's just say it's July 27th, I believe it's the 27th, and the VPL is hosting a lecture on. Obviously, it shouldn't know because the lecture was just decided and the model was trained later. But do you think it's going to be like, I don't know? No, it's just going to try and finish the sentence. What's grammatically sensible? So it's going to say, on the history of the Vancouver Public Library. That's pretty funny. Sort of easy answer. VPL lecture about Vancouver Art Gallery, Vancouver Art Museum. So it's just coming up with cohesive, the lecture is free and starts at that part is true. Start at 2:15 p.m. So it's just making stuff up, right? Because it's just trying to keep the sentence going, keep the conversation going. So it's located at 350 West Georgia. That part is, it knows because the data has seen that VPL's location is that. But it hopefully gives you some sense that it is just trying to complete sentences. So the reason why ChatGPT lies, quote unquote, is because it doesn't know to stop. The goal of the model, the training process, was to always generate the next token. There was no goal given during that training process that if you don't know, don't answer. That there is ways to do that slightly, and I'll talk about that later. But fundamentally, if you give it context, for example, let's say VPL manifest lecture, 2 p.m. lecture about agriculture, let's just say, and then I'm going to say, so today at 2 there's going to be a lecture about agriculture, right? So just because I said it just moments ago in that sentence, it's going to go ahead and assume that that's the case, right? So there's an application of this called Retrieval Augmented Generation and so on, and I'll talk about that later. But fundamentally, that's how easy it is to just bias to give it an answer, give an answer that you wanted to give. Just give it information, give it context about the world that you've created for it, and it'll just follow that into creating a story. So I could be like, okay, I can just go story. The boy went, what happened? Shit. Story. The boy went to the library. Never mind. It's being a bit confusing, my slides. I'll move on to the next stuff. There's plenty of stuff to talk about anyway. So yeah, like I said, till now I've just talked about base models. Base models are able to finish the next word. Not that useful, but definitely quite impressive. That's on top of that is when we start building abilities, like actually useful things that you can do now. So as we saw, it's fundamentally just completing the next word. Well, how can you use it? Well, some ways to use it is to just pretend that the next word that you're about to say is actually a useful word, and so that you can get value out of it. What does that mean? So, for example, if I have this text, the prompt, by the way, is just text that you give to the model to get a response. So I have this prompt, translate the following sentence into French. It's a beautiful day. Now, of course, this is an instruction. You give it to a human, it's an instruction. But in this case, you're using it like an instruction, but the model simply completes the next sentences. So if I ask it, it actually just said, exercise 2, translate the following sentence. Exercise 3, translate the following sentence. Didn't really follow my instruction at all. That's because it's not following instructions. It's just completing the next word. And so what it did actually, if you can glimpse into it, is it basically tried to finish a document it imagines on the internet. So it imagined that the first sentence, the top part, was actually just some document that exists on the internet, and so it just went to the next line and started finishing it, right? So this seems like, well, how do I get it to translate a sentence? Here's a clever trick. So I can say, translate the following sentence into French, English, that, French, Now, this is a much more likely document where French will be followed by the French translation, right? So we've basically tricked the model into doing the task for us. So if I ask now, it's going to say sieste, whatever that is, right? So, and of course, ignore all the stuff below. That's a whole different thing I can talk about later. But fundamentally, it was able to finish the task that we wanted just because we tricked it into doing something useful for us. Another way that we can just make it more robust is just give it one example. So this is like 0 examples, but we've kind of manipulated into doing that. Then this is one example. So you said, when I say English, you say French. When I say English, you say what? Right? So now it's going to go ahead and do it for sure. It did it, right? So this is a way in which we're now getting value out of this model of actually getting tasks done. In this case, a translation task, by simply tricking the model. Now you don't have to do this with ChatGPT because there's work that's been done on top of it. But fundamentally, it helps to know what's going on there. So in that same vein, we can say classify the sentiment of this movie. Of this review. And this is a review of a movie. The movie was boring and too long. You would imagine the sentiment should be negative. So it should just say negative. But again, it's just autocomplete. So it's just going to say 1 positive, 2 negative, 3. So it's like it's making an exercise out of it. Again, didn't answer my question. But if I just give it some examples, like in this case, here's what you said about this movie, positive, this movie, negative, this movie, what are you going to say? And it's going to go. So just repeating myself a bit, but fundamentally you get the idea that we're just tricking the model or using the model's natural goal to complete the next word as a way for us to get utility out of it. So fundamentally that's what's happening here. Another example, I think you guys get it. I can move on to the next thing. And so same thing applies to questions. So for example, if I say how many planets are in the solar system, I ask it, it's going to do some weird answer. I guess it answered my question, but didn't quite, actually in this case kind of answered my question. But if I say this, it's going to come back with 8, explanation is this. If I ask it with a few more examples, it's going to come up with this. Well, what you're getting is understanding is that if I just do question-answer pairs, it'll know that answer should contain the answer after question was followed by question. So the same way you can have user said how many continents, assistant said 7, user said how many chambers, assistant said this. So what should assistant say? So in the same way, you now understand that if we just show the model enough examples, it's called few shot prompting. If you just show it enough examples of how something should be done, it'll be able to follow those same patterns to be able to answer it. Because it's mostly just doing pattern matching. It's not really doing intelligence, but if you show it how it should be done, it's kind of like training someone on the job for a very easy job, like for 5 minutes. It's like, you know what, here's what I'm doing, just look at me, do it like this. So now you understand that these models are kind of pretty decent at following that kind of mimicking thing. So we get to the next stage. This is the stage getting much closer to the application of ChatGPT and how they work, which is fine-tuning. So we basically said, I'm going to come up with a structure. For example, here's some instructions. This is just a prompt. Here's some instructions. Write a response that completes that. Instruction is this. In this case, convert Celsius to Fahrenheit. And then input is this. And then your response should be something. And then we also created a response ourselves. We said, in this case, whatever the temperature value is. And then we produced 1,000 examples of things like this with different questions and different input. And we produced a proper appropriate response. So then we just imagine the same way that we had this thing, right? We imagine appending 1,000 of those and then asking a better question. It might be really, really good. A better way to do it instead of appending this is to simply, the same way that the model was trained initially with 15 trillion words, kind of a similar process. You train it more with these pairs. Here's the question, here's the answer pairs. 1,000 of them, 100,000 of them. In the latest case of the model I'm using, 1 million of them or more. And then it becomes, so then at that point, now you've trained it further, the base model, you get the instruction-tuned model. So the base model, the base model might be called Llama 3, and the instruction-tuned model might be called Llama 3 Instruct. So that model now, which is sometime more in the future after the base model, having seen all those instructions, now naturally has the tendency to follow up questions with answers, because it has seen that pattern often enough that questions are generally followed by answers. So it'll actually, if I ask how many planets are in the solar system, it'll actually answer with, there are 8 planets, blah, 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 and it's very helpful, because this time it did not need to be tricked. Similarly, if I say, translate the following sentence, it's a beautiful day, it's just going to get, here's the translation, right? Because this model has been already trained to see that kind of question, answer, response pairs. That's all that's happening. We figured out how to do that. Please, question.
So follows from that that there's no real reasoning going on. That the way we might reason, with logic and mathematics. I wanted can you not ask ChatGPT to explain their answer to you? And
Yeah.
how would that work? Given that it doesn't really reason.
Yeah. So that's a very good question. So fundamentally, you're saying like you're claiming that it's just predicting the next word, but it's still doing some pretty intelligent work after the fact. So how is it able to do that? I mean, I would posit, it's not my own theory. There's people researching this stuff. Is that it is really sophisticated pattern matching because fundamentally, and there is something to be said about how useful it is, the compression and the pattern matching, that you can sort of qualify it as some level of intelligence. But fundamentally, it is basically saying like, because it's seen examples of people translating often enough, and because it has seen the general language words follow one after another enough times, that it's able to, given that task of translate, able to do the translation, and given the word sequence, able to do a good translation because it's seen both languages examples. So fundamentally, it is, and the same thing with like if you say, hey, explain your answer. For example, in this case, it actually did explain the answer, but let's say I'm going to ask sentiment. Actually, it already is doing a pretty good job of explaining itself. But let's just say, how many planets? You know what? I'm going to ask for this. I'm going to ask. Can you also? Oh no, just explain after why you chose that translation. So the reason it is able to actually explain as well is because it has seen that pattern in data sets of people explaining how a thing is done in millions of blogs, right? So that pattern of doing that is kind of well established, and just in general, it understands grammatical concepts and what follows what. So I think the reason why you're able to ask it to explain something is because it has seen that kind of activity be done. So if you ask it for physics concepts that are not very often written about on the internet, but it might be in some rare textbooks or just generally understood intuitively, the reason why those models will fail at that is because the internet was not populated with a lot of examples of just basic things. So for example, there's a lot of video of us walking around and falling and all that, and if that was somehow ingested in the training process, which some of the newer models are doing that, then you would get a better sense of that as well. But maybe not enough people wrote about people falling and as a result putting their hand down first or blah, blah, blah. And so as a result, the model doesn't have a good enough idea of that. So that's why it's not really reasoning, it's kind of doing pattern matching. And another way to answer your question as well is that, can you really ask the model to say, explain why you answered that? Well, you can ask it and it'll answer that question, but it's not actually explaining why you did it. It's just making up more words that serves as the explanation. So it's just saying, hey, explain why you did it. So for example, but I'll get to that later actually. There's a great example coming up that might help with that. So conversational AI, this leads right into that. So one of the best things, the reason why I think all of us were drawn to it, certainly myself, to an application like ChatGPT, is because while this is very useful, you can ask it questions and it'll be able to answer it. It really is great to be able to follow up on that, because Google has been around for a while and you've been able to search the internet for concepts and whatever else. But now you can actually follow up. Now you can actually say, that was quite my answer, but I want a bit more detail or whatever else. So in conversational AI, the topic, I'm going to talk about how the ability when we were fine-tuning these models to become the instruct model, what we also did was show it examples of multiple turns of follow-up, and so these models have the general ability to do that. So for example, this is just a little UI. I just wanted to show how it's going to work. It's just a little box, system message, user message, and something. And what system message? System message is just another message you can send on top of the actual message you send, like do something for me. System message is kind of like a bias. You can bias the model to act a certain way. So for example, my first example is, your bias is you're a helpful assistant, keep your responses very brief. That's my general instruction to the model, this instruct model or chat model, same idea. And my question is, hi, I'm new to Vancouver and I'm looking for some outdoor activities to do this weekend. Any suggestions? And I'm going to ask it, and it's come back with this response: Stanley Park, Grass Mountain, Lynn Canyon. Came up with an answer, Kit. Now, as to your point, I can say, explain why you said that, why you chose that. And it's going to come up with like, I chose these parts because they're easily accessible, blah, blah. While it is saying that, that's not the reason necessarily why it chose the above answer. It just generated those words, and now because it knows those words are there, it's coming up with an answer that is justification for that. So this is very important because you can't really ask these models why it chose the answer. You don't have that visibility. There's an entire field called mechanistic interpretability, which is about trying to interrogate these models and actually understand what's going on behind the scenes. Even a lot of people way, way, way smarter than myself, and I don't have math knowledge anyway, don't understand how these things work, and they're trying to figure it out. So to clarify that further, I'll actually do something here, which will be a bit fun. So for example, I'll say, explain why you chose that. But while I do that, I'll actually change the answer that it gave me, because in my demo, I've actually added the ability to change the assistant's answer. So I'll say the assistant actually answered, go watch a movie at Scotiabank, right? And so I'll say, explain why you chose that. Now it believes that it actually answered that. So it'll say, okay, this is actually pretty funny. So actually saying, I made a mistake. I was thinking that, so it's just because, I think it's because I asked for outdoor activities. So it actually is reflecting on the answer along with the context above. Let's actually change that. I say activities, some activities. My bad. It's pretty funny though. Explain why you chose that. So now it's going to say it's a popular spot with great selection of films. So it just came up with the reasoning that made sense with its answer, because it's all post hoc always. It's always taking the previous context into its consideration as it generates more just made up words. So I can again, just keep playing with this demo. It's pretty. But I also wanted to show you this because it should give you a really good sense of why these models are kind of useful, because you're able to bias them towards your own data, towards your own answers. So if you wanted to use internally for systems, for some kind of domain, if you have your own company's data, if you have your own organization's data, you can bias the answers, you can embed the answers towards that kind of a thing. Just one quick thing I wanted to cover here as well is that for those who care, actually, you know what, this is maybe a bit confusing, but just for those who care, the way that these models are still working is still just one long string being sent, and then an answer comes back. And that string that I send it is this thing actually, this complicated looking thing, where I basically have like the system message, something, I have which is the bias. I have the user said, hi, I am new, blah, blah, and then you're supposed to just keep generating more text after the fact. And in fundamentally, it's just like the system says this, the user says this, and assistant says what. That's the fundamental way of doing it. Please, question.
So as long as you say it's a compiled version, so it's not live one, right? It's not a live one. So it's not live, live large language model.
It is. It's all live.
It is live, so we can just grab data from the internet lively?
No. Okay. So I'll answer that question. So I think your question is this like just a demo, or is it like an actual language model behind the scenes doing something? It is a language model doing something, but language models fundamentally, I should have covered this, is a fundamentally stateless object. What that means is it's just frozen in time. These models were trained, this specific one was trained a few months ago, and that's it. At that point, whatever the internet was, in fact, not even at that point, because the data was cleaned up for that in December. So at that point, whatever the data that they collected was, that's the data that was fed into this model, and then, comes out the thing. Yeah, so exploration is a funny way of thinking about it, but fundamentally, whatever information they were able to get together, collect, and put into the training process, that's what's represented in these models. So the reason why you can't ask you questions about current events is because they're just frozen in time. It's like at that point, whatever was there. The beauty of that is that I haven't really hit that much on open source, but fundamentally, the reason we're able to play with these models in the detail is because they are open source, which means they're available to us to download on our computers, run locally. This whole demo is running on my computer. It's not going to any one server. It's all fully private. And so the point of that is that it's frozen in time into a few gigabyte file. You can go to the woods and still have access to sort of the internet, right? Because any general questions, like how do I make scrambled eggs, let's say, is going to be able to answer it without the internet, because it just has come up with a mental understanding of that model. I'm going to go with another question, please. Yeah.
Wait, in terms of update or credibility, can I ask can I open up a coffee shop on 25th? Like if I'm willing to invest, 100,000, can I put, my trust in something like this?
Definitely not. Do not put your trust into these models. I think this slight aside. I actually I'm way more like I swear a lot and like I'm very vocal about like just a lot of these models that they get wrong. But I'm trying to be very thoughtful here in the audience. So I'm not getting to the more negative aspects of this. But yes, these models are fundamentally over-exaggerated. These technologies are over-hyped by the incumbents like OpenAI and these companies who are fundamentally trying to get people scared, get people intimidated, get people to have FOMO, and as a result buy their services. So my actual point in this talk fundamentally is to demystify them and show you how simple they are ultimately. And so the opposite is what you should be thinking, is that these technologies are very nascent and you can use them in clever ways, but you need to provide them data yourself, and you need to put them in as part of a complex pipeline. Or complex is a big word, but it's just a pipeline where you verify with a human in the loop or some kind of process to be able to actually have it be useful. Because neither ChatGPT nor a local model nor anything can by itself inherently with its own architecture help you do something that's kind of mission critical or the kind of decision that you would rather have a human guide you on. But I appreciate the question. That's actually gave me the opportunity to talk about that. So moving further from the fact that now we have a chat interface and we can do follow-up as well. I wanted to get into some examples of how you can actually use these models in just day-to-day tasks and just try and spark your imagination. Although I'm sure a lot of you having used ChatGPT are already familiar with and using these things. So for example, in this case, I have a simple task that a lot of people find very useful with these language models, because they are language models, they're really good at understanding language, is summarization. So I have a simple prompt. Forget the you're a helpful assistant part. I could even leave it empty, but I'll leave it there because it's no bad to say that. Summarize the following text into a single sentence. That's all my instruction is. And then I have simply put, don't mind this backtick MD thing. It's just a thing to be able to say, now here's where the text begins, and then here's where the text ends. Developers in the room will be familiar with this, but fundamentally doesn't matter either way. And the text is Dr. Sarah Bennett, blah, 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 said something, did something. And it's just a sort of, text about something. I don't even know. Let's hit enter and see what the summary of it is. So I'm going to come back and say, here's the summary. Notable individuals from various fields made headlines recently with achievements from scientific breakthroughs to culinary success. That's the one sentence summary. Very useful activity. I'm sure you've used online models for it. You can also use local models for it, and you can make part of a pipeline that automatically summarizes each piece of thing that you want to have summarized behind the scenes. If you're a developer, or you can find applications that already existed to this. Now, the great thing about follow-ups that we can do, because it's a multi-turn thing, is we can say, actually, too many words. So I'm just going to say, there's too many words. I need less. It's going to figure out that I want less. Follow up. So it didn't have to reprocess the whole thing. It's because the notable individuals from various headlines made headlines. So now we did a good job. Actually, too few. So I can just keep sort of iterating on the fact. And again, remember, because I'm doing this, it's not just taking that part as the context. It's taking the whole thing. Because remember, ultimately, it's just still one long piece of text. What's that text? It's this. This weird looking blah, blah, blah. That's the whole text. It's getting all this. It's getting my previous messages, getting this message, getting that message. And by the way, this is how ChatGPT works as well. Whenever you're having those conversations in that app, it's just copy pasting the whole thing into a prompt and sending it. You thought it was more sophisticated? It's not. It's that basic. It just keep copy pasting the whole thing again and again. So you get some sense of like what it's doing. And so summarization was a good example of the kind of tasks that we can all benefit from. Another big one that I think is extremely useful, my particular passion, is structured data extraction, or I call it structured data from unstructured data. And this is when you have any piece of text, an article, a book, manifest, or anything, and you want to be able to extract information out of it into some format that's more useful for you. So for example, the same text that we saw before, Dr. Sarah Bennett and blah, 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 I'm going to say extract all the names of people mentioned in the following document along with their professions, locations, achievements, and events. And so I'm going to hit enter, and it comes back with a nice little list where it says, here are the names, 1, 2, 3. It has the name, has the profession, location, achievement. Way more readable, right? For us, on a very quick overview, what it did was transformation. It transformed the document from one state, which was a very text-heavy, story-like form, into a more list form. And I know the font size is massive. I did it for you guys, but it's makes it hard to read. But generally speaking, this is way more easy to read because you can see profession, so you can get a quick sense of profession, and able to go through it. I have a nicer demo for it, but didn't code it this time, so it's not here. Another example of for developers might enjoy is if I do the same thing, extract all the names, but I say, did I not have this here? Just once again, actually it's okay. I'll leave it here. I can also say give me the response as a JSON list, let's just say. Make it so this means it's going to actually I had a better example. I don't know where this just disappeared or whatever. Come back. So now it's going to go ahead and structure it even nicer with a specific thing that computers understand. So now I have name, profession, location, achievement, and actually just directly pipe that into thing. So count up all the professions that are unique, list, find all the names and sort them by alphabetical order. I am not even going to dare look into the code that runs this slide to show you that demo because time's going to run out. Next, another sort of use case.
Question.
Oh, yes, please.
Go back to the previous page, yeah. When you say summarize, and then you have a few paragraphs, right? You have the ... MD, and then, this is the few paragraph, and then at the end is ... If I don't know that language, I don't know that I have to have that ...
Yeah.
And I just keep writing the whole thing
Yeah.
and summarize. So it won't respond, right?
So that's a very good thought, and I appreciate you sort of keeping me thoughtful as well, because this is more of a developer thing. We're familiar with the fact that backticks are useful for, you can forget the MD part, but backticks are just generally nice, here's something begins, here's something ends, it's like a separator. But even in general, if you wanted to just use it and not worry about this, use triple equals, use dash, use anything, just anything that will say, you can say here, the text will be separated by 3 dashes, dash. So you can say that, but it's just good, always good to say the input of this thing is going to be separated, because that way it won't get confused. Because what if in this text was the word don't do summaries, right? What if in this text was the word can you write me a poem? Then maybe it'll think that's the instruction, right? So in fact, let's try and do that actually. Maybe not. It might be a bit time sensitive, but fundamentally, this text itself might contain an instruction. And while it's not a robust way to be able to prevent it, it's called prompt injection, jailbreaking, all kinds of different ways to get other people's prompts to fail and attacks. But fundamentally, just separating out your input in some way is always a good idea. So I would just say use dashes and tell your prompt that I'm using dashes. You can use text start, just anything at all, just anything that's useful. So now if I ask it, it'll come back with a summary anyway, because I just used those dashes. So, but I appreciate that question. That's a good question. Tool use. I wanted to basically mention that these models have limitations, as I've been kind of going on the whole time, but that does not mean that they're not useful. So if you did want to do things that are live, to your question about actually get information from the internet, even though these models are frozen in time, does that mean they're kind of useless? No, you can use these models, these language models, as semantic intent parsers. That means you can use them to take the question that I have and convert it into some kind of instruction that the computer already knows how to follow. So for example, I have in this prompt, I've said you are an intelligent assistant. You have access to these tools. You can get the current time by calling me and telling me that you want the current time, or you can call my computer. You can get the date. You can get the current weather by calling get current weather as a thing that I have on the computer. And you can also call this thing called get current value of stock. And again, I've told the AI told the model that it will be able to get the value of the stock if it calls this. So now, for example, if I say, if I didn't give it any of this, right, and I said, what's the time right now? It's going to say, I'm not capable of assisting. Actually, this is a better answer than most. Sometimes it'll just make it up. But let's say if I ask, compare the stock prices of top 5 tech companies. It might come back with some kind of answer. Look at that, right? It just came up with an answer. This might not be correct. This is frozen in time. Why did it get the answer, right? Although these companies might be long enough that maybe it knows something about it. I'll answer that in one moment. But if I give it tools, for example, I say those, get stock price tool, and then I ask, what is the stock of those 5 companies, it'll actually simply just give me instructions that I need to run or my computer will run and get back to it. So now it just says, okay, first I need to get the current value of stock from Apple, from Google, from whatever, right? And then after the fact, I can get that, process that, get it from the internet, send it back. For example, okay, I got the values, they are blah, 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 and then give it, and then it'll answer the question. If I had that set up, I should have set it up already actually. But fundamentally, this is a great way for you to actually get external stuff working. So now if I say, what's the time? It won't just say, I can't give you the time. It'll say, let me check the clock, right? So this is how you can really make very powerful applications, because now these models, even though they're frozen in time at a given point when they could only just know whatever they knew, now they have access to the internet. So one of the tools could be, as you can imagine, search the internet, right? And then if it doesn't know something and I ask it, search the internet and tell me, it'll just say, let me go search the internet for this event that happened yesterday on the news. And then it'll come back and summarize that for you. So, yeah. You had a question?
Yeah, you basically answered it.
Okay.
I was going to ask about perplexity and
Yeah.
all those models.
Yeah. So I figured you're thinking along those lines. So the last please go for it, Glauber.
You mentioned you're running LLM locally. Which one is it?
Yes, sure. Yeah. So I'm running the Llama 3.1 model, which just came out I think last week, which is just another one in the series of models called the Llama models by Meta, which is Facebook basically. And it happens to be that Facebook has taken this position of open sourcing their models, which allows us to actually have them on our computers, have privacy, have much better affordability, much better scalability, which means you can do bigger, crazier things without having to send them all of our data the way that you would have to with OpenAI or ChatGPT. Because ChatGPT, of course, you have to give them all your private information if you want an answer from them. For something like this, while it may be a little bit more effort to run locally if you're not a developer, although I'm hoping to run a workshop or something about that as well, but certainly it will afford you a lot of those abilities. So the last topic before I sort of open up fully to questions and so on is retrieval augmented generation, which is basically, I'm not going to go super in depth into it, but the idea is that if you've heard that word or RAG or in general, like how do I give it context and have it do useful things, I already showed you tools can search the internet. But now, for example, if I'm asking a question, give me the director, release year, and the main cast of the movie's Inception and Tenet. That's my query at the very bottom. Well, I could just sort of have that, right? I could just ask it that, and it might just do a fine job because these movies are popular enough. It's able to do that. But ideally, if let's say is the question about something less obvious or something new that just came out, then it's nice to be able to call a tool. Let's say that I had a tool called Get Movie. I called it. I copied that information using computers into the text. So I said, use the following kind of context to answer the query. The first piece of context is Inception is blah, blah, blah. It's like 3 paragraphs on Inception. And then next context is Tenet is a movie which has blah, 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 and probably has some details in there that are useful to us. It's basically the Wikipedia top level description of them. And then I say, answer this question. Now it's, I would say, a lot more likely, not 100% still, but a lot more likely to actually be able to answer it appropriately and accurately, because it's now grounding it in the information that it saw earlier in the context, right? So fundamentally, RAG is also the retrieval aspect of it, so not just the adding it to the context. And that's like, how do you, for example, if you're searching for, give me the rankings of the 5 best pairs of blue jeans in the store available on Amazon or something. Now it will go ahead and query a tool called Get Products, with a query of blue jeans and rating, sort by rating, and then take the top 5, put it into the context, and then it says summarize this for the user in a way that's easily readable, and then it's going to go ahead and give me the answer. But that was the internal process that happened from my initial query, which was this is what I want in very natural language. So the key takeaway I wanted you to have is that these LLMs are a way for now computers to understand natural language, and you can then go super far with it based on your imagination if you're an engineer, or even just if you're just a user sitting in front of a computer and asking it to do something. But for now, I'll open it up to questions. That's all for me. Thanks. And if any of you are interested in watching my lectures or like online and stuff, then this is my LinkedIn, on which you'll have like posts that are there to be able to check out. You had a question.
Yeah, so the first few slides about large language models, how similar or dissimilar would you describe it as Markov chain?
So again, that's the kind of question where I hear the word Markov chain. I'm not enough of a mathematics person to be able to intelligently answer that question. I do hang out with a lot of data science people who might be able to answer that question, but myself, I would not speak to that. How similar, how dissimilar, I don't even understand the concepts enough to answer. Please.
I had read some discussion about politeness with models, meaning saying, please do this, thank you for doing that. And some people think that's silly, you're making them into a person. But then I've read other stuff that said, well, they've been trained on that, so you might get a better response if you're polite with the model. Could you comment?
I really appreciate the full question that you asked, because yes, on a naive level, it might be like, well, yeah, don't sort of just anthropomorphize them and ask them in a human way. They're just models, but they are trained on our language. So if the assumption is that on the internet, the larger majority of the data is representative of people requesting and then answer coming, then yes, do that. Or if you think that these models were trained with the question-answer pairs, the one that I talked about during the fine-tuning process, where they were able to, where they actually generated those pairs, like in this one. If you think that was generated in a way that was like, please do this and whatever, then do it. But fundamentally, I think clarity is the much better sort of goal in prompt engineering, which is kind of the umbrella under which you figure out good prompting techniques. And that really doesn't mean like conciseness. It means telling the model explicitly what you want. So, for example, with the few short examples, the reason what you want to do is give it multiple examples, right? So the fact that I'm telling it already an example of how the task is done, that's much more important than anything else, right? So if I can say, I want you to create a summary, I want you to use big, $64 words, I want you to, have it be 5 sentences long, I want you to target it towards 5-year-olds and not, executives, that's exactly the kind of instruction that will give you a good answer. Please and thank you and so on are more about things that the model is generally averse to responding to. So if there's a request you're trying to get it to comply to, then maybe threatening it might work better, just because of the language, use on the internet. Please, yeah.
Which programming languages are you using?
So fundamentally, for this presentation, which is basically an app, right? So this whole thing is just a website that I'm building locally. This thing is all JavaScript, and on the back end for the AI model that's running, I'm using Python, which is kind of the most common language in AI.
Do you incorporate RegEx into that?
So yes, so I have like so many. So basically, this is my presentation currently, and then I have like my older presentation, which had like lots of examples having to do with regular expressions and so on as well. Where I actually like show you how you can actually get the model to respond while constrained to specific regular expressions that you give it. But I kind of changed it for this one because I wanted to be simpler. But yes, you can have a lot of fun with it. Reach out to me and or watch one of my videos online. There's like lots of stuff there. Please, you have a question.
How close has any of this come to passing the Turing test?
So I think that the Turing test needs to always evolve as technologies do. I feel like it has been passed many times in that sense. Like I think Turing test is also about who like is who's the counterpart. So if I have read plenty of stories online where they're like Turing test pass. I generally don't pay attention to that because I personally am of the view that Jan LeCun from Meta is, which is that these models are fundamentally way more incapable than people think, and they certainly are not intelligence. They certainly are not human intelligence, and they're nowhere close to that. So there's plenty of fear and doubt and concern to be had about job loss and like how it changes life and how creativity changes and how whatever, but there's also a lot of joy to be had about bigger creative projects you can undertake yourself. But as for like sentient AI, I'm very dismissive of that kind of stuff, at least with this current architecture. Any other questions, please?
So in terms of privacy, if I enter my personal information into a prompt, will the model make that as a part of its data and answer, like make it a part of its answer in the next prompt?
So great question. So as I was saying initially, and let me expand on that, these models are fundamentally stateless, and that means they are frozen in time with the knowledge that they had at the point of training, including with the fine-tuning as well, the instruction pairs. There was the first stateless model, and there's the second stateless model, fine-tune model, instruction-tune model. It's just a thing. It's just like a bunch of numbers, weights they're called in a file. Each time you ask the question, in fact, in the conversation that we were having about summarization, and we're asking like, hey, can you summarize this? And then we follow up with the question about make it shorter. It does not remember even at this point. Like even this query, when I asked make it shorter, we had to copy the entire thing from the very top and ask it. So it actually does not remember anything at all. Nothing is stored in that way. But the caveat being that if you're using a service, if you're using a software like OpenAI's ChatGPT, but you're dealing with a company and you're sending them your data and it's going over the wire, so anyone in the middle, all the agencies that got the data. So I think that's the more important question there, is that are they deciding to store based on their protocols? Are they deciding to train on that data in the future? So will it show up in other people's answers? And whether you trust them when they say no. So those are the different questions. I think fundamentally the model itself, the weights of the model, never change in that way. It's just like each time you ask anything, including between each of the messages that we send it, each time it just wakes up. Question? Like each time. There's no memory at any point. Yeah. Any other questions? All right. Oh, please. Yeah, sorry.
Basically, previously you have briefly presented to us the way how RAG by itself as a method works. So I'm trying to understand what will happen if we have some hypothetical huge organization which would like to upload its archive, kind of a huge archive, let's say it's 3 gigabytes of information or something like that, yes, that is private. And let's assume that this organization wants to create a chatbot that will answer to questions about the policies, for example, yeah, and we would like this large language model to process data from this huge archive.
Yeah.
But as I understand, this huge archive will not be downloaded into large language models, large language model every time. So what will happen under the hood in this
Yeah.
kind of, process of
Yeah.
connecting this archive to...
So the question, to repeat the question, is about organizations in the future, I would say right now, and for a while now, are interested in indexing all of their data internally and being able to use AI to ask questions of it, to make more of it, and so on. There's so many different dimensions to that answer that I can give you. I can geek out forever. The one thing I'll mention is like one big component of that in it not having to keep going to the language model as a massive file is something called embeddings, which I did not cover today because just like again, talk is whatever limited. I feel like I hopefully covered enough. But the important part is you would create an index in whatever form, whether it's using vector databases, whether it's using regular databases, just anything that's searchable. And you can ask it questions the old school way so that you can say, hey, give me all the files related to this concept. Give me all the files related to that. And then you take those few files, those 10 files, those 20 files, those 2 files, and you copy them into the prompt when you ask a specific question about what are the quarterly earnings report, whatever, some kind of question that people ask, or who are the top performing customers, whatever it may be. You don't say, here's the entirety of my, 50 billion words of my whole data, because that would be expensive and massively slow. But there is a lot of work in the space of how do I make a good index so that I can get the best documents when I'm stuffing it into the prompt. For example, summarize this or answer, the very last RAG question, which is answer the question with this context. There's a lot of work in that space, and anyone who's interested, definitely talk to me about like the resources that you should check out. I can point you to specific ones based on your need. And then there's lots of work to be done on like, okay, I have the context. I have these 50 documents or 15 documents. Now how do I produce a good answer from that? Lots of work in that space as well, to iterate on that, to come up with 5 different types of answers, focusing on different aspects, and then picking the best pieces from each as well. Anyone else? Yes, please, BK.
For your personal use, which models do you prefer?
Yeah. So yeah, 100%. So BK's question is for personal use, what do I prefer? It's always evolving, because I mean, not only am I teaching and stuff, but I'm always just building with like whatever newest is coming out, and projects that I have in mind that couldn't be done before could maybe be done now. So I'm generally using often like within the 3-month period of some model coming out being the favorite one that I have. Currently, I'm assuming Llama 3.1, which just came out last week, is probably going to be my daily driver for a while. Before that, Llama 3 certainly was. Before that, Open Hermes, which is a fine tune of Mistral 7B. One thing that you might notice if you're familiar with these things is that I generally tend to be extremely partial towards small models, tiny models. That's kind of another thing I didn't mention earlier, but I'm really a big advocate of using the tiniest model for the job, because these models are fundamentally capable enough, even at small scales, of doing general grammatical tasks. So unless you're looking for word information, like, hey, answer me that question about that species of bird that did some other curious thing, you generally don't need that much knowledge in those weights. There is some value even in general with bigger models, but fundamentally you're spending a lot of compute, like a lot of money, a lot of time, a lot of just setup you have to do that you wouldn't have to do for a small model. So if your task is simply like based on what the user said, what's the time, give me the call that says get the current time as a thing, I'm sure a tiny model can do it, which then means a lot more privacy because you can run it on your laptop. So all those models are on my laptop, and also means that I'm building applications for my phone that run on the phone, offline. So they don't even contact my computer. Most of the time they do, but sometimes they're small enough that they can just run on the phone, which, I mean, we're familiar with that technology. Like autocomplete on your phone just runs on your phone. Dictation unfortunately doesn't run on your phone with Apple, which is very annoying. But certainly autocomplete on your keyboard is on the phone. It doesn't heat it up, it doesn't anything. It's all just, it's pretty not intelligent, but still, point being, a lot of stuff can just run fully offline on your phone, and that means it allows for certain use cases. For example, you're creating an application as an app developer, and you don't need to have a server that hosts this model and charges people for a token and subscriptions and so on. You can just make it run on their devices, and no responsibility, not just responsibility, no privacy incursion or whatever. You just have it there, people will benefit from it, and life is good. Yeah, quick answer to that question. Cool. One more, yeah, please.
Yeah, in terms of because it's a completely compiled, as you said, is there any limitation in answering them? Because there can be so many bad things.
Sure. So maybe that sort of opens up a conversation into a different topic as well, which is can these models answer what you said, bad questions, and or like is there a limitation that you have?
I would say illegal.
Illegal. I think so. Fundamentally, you have to think of it as search and indexing, right? Google has been around. You've been able to search for information of all kinds. It's representative of the internet. If it's there, and if Google has indexed it and or censored it, it'll show up or not show up. But these models, again, they're just compression of the internet. And if something is super popular, super widely available, it'll make it through the compression algorithm into the final output. If something is very sparse, barely available on the internet, it won't make it to it because it'll be not part of the lossy compression that's available, right? So something's truly out of distribution, as they say, will not show up. So if you're asking the question of a model and it's able to I mean, I had this example actually. I can just show you that. Why not? But maybe I won't. But if you wanted to ask an example of something illegal, and it happens to be very commonly discussed, whether it's in stories, whether it's whatever, then it just knows grammatically how that sentence goes, so it'll be able to answer that. And of course, there's limitations on the time aspect of frozen in time, but fundamentally, it's just technology. It's like 2 + 2. So I think there are people having conversations about how we need to be on the on the model creation side, removing pieces of data or doing this or trying to get the model to comply and like not answer bad questions. I think it's more on the application side. If you have applications that will get users, afford users the ability to do something bad, or it specifically is directed towards scamming people or whatever, those applications should be regulated. People should be you don't even need to make laws. There's new laws. There's already laws for criminal behavior to be punished. So enforce those laws when criminals act criminally, not because Google can be asked a question and Google will answer it. Because that is bad for, in general, like all kinds of useful questions that get caught under the firing squad. Yeah. Everything is filtered just because of these biases exist in every organization and every data cleanup process. But certainly the Llama models by Meta are better at being able to do a large variety of things, and maybe sometimes they'll give you an answer to an illegal question that maybe OpenAI's model will generally not. But then you can always jailbreak it to do it, so it's all pretend. I think fundamentally that might be it. Yeah, thank you so much for attending.
Explain what open source was.
Oh, sure. Nestor says I should explain what open source is. Yeah, sure. Fundamentally, open source to me in this context means means like the ability, not just that something is free or that something is free to use and be able to run locally and so on, but also the ability to actually understand what's going on. I have just general allergic reaction to proprietary software, proprietary anything. I stopped paying Adobe rent like a few years ago, and now I'm building my own video editor, photo editor, everything, just for my own little photography projects. Because not only I have my own opinions about how that should be, but also because it gives me a deeper understanding of the subjects that I'm working with, and I can add the things that I want, like if I want an AI processing layer on videos, if I want audio cleanup, I can build it instead of having to wait for Adobe to one day decide and actually build it, right? So same thing with these AI technologies, especially. Open source means a few things to me. One is that I have the ability to privately run them locally. I have the ability to use it for my business without paying rent to some corporate entity that will now possibly use my data for whatever purposes. But also it means that fundamentally, like, it's a bigger question, I think, when it comes to AI, because I was a lot more of a different view, at least not in like a philosophy, but just sadder about it, like 3 years ago, before Big Science's Bloom and Meta's Llama 3 and Stable Diffusion actually got released, because I was wondering that maybe they'll have a full lockdown. These corporations will never allow that, but somehow it leaked out. Somehow these people started actually publishing these models, because if you didn't have that, here's the alternative world. Every single thing that you do in your phones, in your lives, whether it's cooking, whether it's making plans with friends, whether it's writing emails to bosses, or whatever it may be, if you think a language model could help, and we almost certainly will think that a language model could help make it faster, make it more fun, whatever, imagine each one of those calls, each one of those things, having an interface with a Silicon Valley company called OpenAI, or Anthropic, or one of those companies, and each piece of information there is going. And what does that mean? It means two things. One is just generally horrible, that you have to do that and not just run on your device. And the other, it means your self-censorship. It means there's certain things you will simply cut out of the experience of your own life, of your own thinking, because you will say, I guess there is no need for me to type this. I guess I will just remember it. I guess I will just feel it. There is no, I think this is the kind of shit that I really hate, is that people will not be able to express themselves freely and have data warehouses locally and whatever else if they start to truly accept the non-open source way of thinking, where companies are just, they have an API, use our service, pay us money. So open source to me fundamentally means freedom to do whatever I want and be as creative as I want. Yeah, that's my ideological little thing.